what color I'm using. I don't know what the last color I used was.
What do you mean just here?
Did I?
You said just here.
I typed my name.
You said just here.
I hate autocorrect so much.
That's
Oh
funny.
my goodness. Just here.
Why would it autocorrect from Josh?
I just couldn't tell you.
It's okay. I tried to say gotcha one time and I said goths. And I was like, that's not what I meant. Oopsie doopsie.
Alright, finding normal percentiles.
What was the color I'm using?
Wait. Is this where we left off?
Yes.
Well, it's the next topic, but yeah.
What was the last thing that we wrote?
Gas mileage between 20 and 40 miles per
It's
gallon.
right, yeah, it's right above.
Oh, I was on the wrong.
You in the wrong chapter?
When did you
Yeah.
put your sweater on?
Oh, it's always been like this, Josh.
Yes, it literally was.
He literally said, I'm not burning up anymore, I'm freezing.
Oh, I remember that.
Alright.
I have amnesia.
When a z-score isn't exactly 1, 2, or 3 standard deviations, we have to use a z-table. Okay, I am pretty sure, you will have to check because some of the books are different, that the table in the back of your book, it's either 74, which I think is the student book, or 102, I think in the teacher book, is where that is. But some books I want to say were like 72. They were like off a little bit because they were a slightly different version of the same book. Or a calculator. That's the other option. The z-table tells you the percentile value for any z-score. So, for example, the normal model for SAT math tests is in 500, 100. What percent of students score below 450? Now, for the moment, when we do this, I'm just going to have you take my word for it, but I will show you the tables later. But it's easier to see in like the examples that we're going to do later, so.
No way my math score was below 450 on my PSAT. Because I got an 8 on my PSAT. 840.
All right, now this picture wouldn't be given to you. You would be drawing it yourself, but we're told that the average is 500, standard deviation of 100, so I'm going one standard deviation away. Like just drawing out. I'm not drawing all the other ones. It's not really necessary. So I need below 450. So I'm looking at basically this area in here. So to find the z-score, we would have 450, so that's the actual value, minus 500, the average, divided by the standard deviation, which is 100. And that's going to be minus 0.5.
How are we gonna count that 500 is the average?
So the normal is always going to be your y bar and your standard deviation. Or I guess for the normal, I should technically write mu and sigma officially. Now, from the table, we would get a value of 0.3085, okay? Now, after we're all done, we'll get out the tables. I didn't realize that this was in this section. I would have already copied them. Actually, hold on. I may already have them copied. Some years I copy them and then like forget and then I make like 82 copies.
That's fine. That's so. That's like the same exact.
Literally. I think I did it better.
Nathan, try
I
to
do not.
make a train whistle.
Only if you want to be recorded.
Who's gonna watch them? Who would watch them?
If she makes us a flip class.
If it's a flipped classroom in the future.
That'd be funny.
Okay, I don't have them printed yet, so I'll have to print them. But anyways, basically from the table, we would get this value of 0.3085. So that means that approximately 30.85% of test takers score less than 450 on the test. And so when we're done, if we have time today, we'll go through the book and I'll show you where that number is coming from.
Okay, so it's not a number we have to find, it's like a number that's like already there.
Yeah.
Bad recording. If we could have recorded it better.
Josh, I will not do train whistle because I believe I've already had my fair share of moments in stats class.
You've had a lot of moments.
I've had a lot of moments in this
Not
class
just since that's class.
that have been recorded. So that's
It's
just
just,
how
I have a lot of words
It's
that
just
are recorded on my phone. That paper said. So.
All right, so basically, I'll go ahead and show you this one really fast. So there's this lovely table in the back. Okay. So what we do, we found a z of minus 0.5. Okay, so we come down in this column in z.
What is that?
It's a
Massive chart. Did you just look up?
Did you just look up?
I was like, I thought he was like
I know.
shaking about the hand.
Yeah,
like,
me too. I was like, what?
I just don't know.
You might as well have just train whistled, buddy.
Yeah.
I can't see that. There's like a glare.
Just listen.
Okay, well, I'm going all the way down here. So the right-hand column is the z, okay? So you're going to have a z of some number. So it could be like negative 3.1, okay? The second decimal place comes from the top, okay? If we had negative 0.5. So I come down here, negative 0.5. Now, we have to have a second decimal place. We didn't. So it's a 0. Okay, there wasn't one written, but it's
Yeah.
0. So we come down here, and this negative 0.3085 is where that came from.
Huh.
Okay.
Nice.
I understand.
And then there's a positive table as well. But like I said, yours is on a different page than mine, but it is, the positive one is done the same way. Okay. So then another example of this, it's a little different. So this one was less than 450. Sometimes we want to know about a percentage that are scoring between two values. So what percent of students score between 450 and 600 on the test? So I've got same thing happening here. Okay. I want to know between 450 and 600. So I care about this region in here. So now what I do is I need to find the z-score at each end, okay? I only needed to do this part right here, the 450, when it was less than 450. But now that it's between, I've got to find both ends of it, okay? Because what this percentile does is everything before it is included. But now I only want that middle region, okay? So I'm going to do z of, and just to specify what I'm doing, z of 450 is equal to, and then this is going to be the same one that we already did, so I'm just going to copy it down really fast. Now, ordinarily, if I had already done it, I probably wouldn't do it again, but I want to make sure that if you go back, you see what's happening. Yeah, I would just note, like, see previous problem or something if I had already found the value. And we were told that that was going to be 0.3085. Then z of 600, is going to be 600 minus 500 over 100. Now that's going to come out to be 1. So, just so we can see a positive 1. Now notice, this has no decimal points. Okay. So when I do it, I'm going to be in the 1.0 column and then the 0.00, like that row. Okay. Or, well, I guess I said it backwards, but. Okay. All right. So I come down to 1.0, and then I have this is 0.0. So the value is going to be 0.8413. Okay. So now, that hasn't fully answered our question, okay? Because right now that's told us a little bit about it, but not fully answered the question. We want to know what percent of students score between that. So we're going to subtract these two numbers, okay? So we're going to have 0.8413 minus 0.3085. And that's going to be 0.5328. So basically what I have done is I have eliminated this region over here in white on the left. Okay? Because essentially that got counted twice and I don't care about that part. I only want from 450 to 600. So that's why I'm subtracting it. So then my conclusion is that approximately 53.28% of students score between 450 and 600 on the test. Now, there are ways that your calculator can do it, and I want to say this is where if you have a newer calculator, like the ones that are in color, yours will actually be done differently than those of us that have the old one. We're not doing it right now, but it can be done that way.
Okay.
We'll do that in examples, like actual examples. All right. Percentiles to scores. So we can also use the z-table to determine what we call cut scores for specified percentiles. We find the corresponding percentile in the z-table, translate it into a z-score, then we can use the z formula, which is what we've been using. The z is equal to y minus mu over sigma. To find the cut score. So pretty much the opposite of what we just did. So before we were finding the percentile, now we're going to be finding y basically. So to keep with kind of the SAT example, what score marks the top 10% of the SAT test scores? So again, they don't give you these graphs, but just for reference. So the top 10% is going to be up in here. So this is going to be Z for the 10% at the top. So the top 10% is the 90th percentile on the Z chart. So we kind of now use this table backwards. I'll let y'all get that and then I'll show you. So basically we're going to be finding the closest value to 90, okay, so to 0.90, that's over, okay? So we can't use something like 0.89. It needs to be 0.90 something. If there's not one, that's 0.9000, okay, for the percentile. So it's kind of just like almost like a seek and find.
Mhm.
Now, what I'm going to show you about the table is that they go in order, left to right, top to bottom. They get bigger or small, bigger as we go. And then the negative chart and the positive chart, same thing happens. I feel like we've already been in this class forever, and it's not even 2 o'clock yet.
It's not.
No.
I feel like calculus just kind of like
Ran into it.
into it. Yeah, it just felt like it did.
Just because it's fun.
I need my pencil.
Do you know what time the middle school game starts?
5.
So does yours start at?
All right, so looking at this chart, okay, so we're using this now in reverse. So notice that we start here at 0.5, it goes across left to right, and then as we go down, it gets bigger. So I'm going down and I'm looking for, I need 0.90 something, okay? It's not going to typically be perfect. So I'm going to come down here. I got to 0.903, so I'm going to back up and see if there's anything closer. So I'm going to go up one row, go across.
Yeah.
So I've got 0.9015. So that's the closest I can get. So that's what I'm going to use. Okay?
So you don't want to go with,
You want to be above.
okay.
Because I want that top 10%, which is the 90th percentile.
So that's why we didn't go with the 0.8997.
Correct. Yep. So 0.9015. Now, that's going to translate. So now we have to read the chart in reverse. So 0.9015. Need my hand back. Where'd it go? Right here. 0.9015. So that number translated is coming across here. So 1.2 and then 0.09. So 1.29. Okay. So 1.29 is my Z value. Need a bigger desk. Or less stuff. Probably just a bigger desk. Alright, so now we use this in reverse. So I have normally Z is equal to Y minus mu over sigma. I'm now trying to find Y, so I'm going to plug in everything else. So 1.29 is equal to Y minus 500. So this is still the stuff that was given to us originally. Divided by 100. And I would say when you're doing these problems, always show me what percentile number you end up using, because if you hypothetically used the wrong one, then I can at least say, okay, they just used the wrong one, but they had the process right. Because otherwise I'm going to be like, where did they pull this number from? Like, where did they get 1.30 instead of 1.29? Like, why did they get that, you know? So, all right, so multiply by 100, so we get 129 is equal to Y minus 500. Add 500 over, so we get 629 is equal to Y. So the conclusion is that scores in the top 10% are 629 or higher. All right, so this last stuff it's still notes, but it's just about how to use your calculator and what functions it is. So we may actually go, since it looks like we're going to have a little bit of time, we may actually do these on the calculator as well. Potentially. All right, so if you're using your calculator, and you would think by now I would remember if you're allowed to have your calculator for the entirety of the AP exam or not, but I don't. So they do give you these tables, though. So, like, they would give you a Z table. You're not expected to memorize that.
Hallelujah.
Okay?
'Cause
If
I
you
would
switch to
fail.
dual enrollment, I'm pretty sure they're going to give you a Z table or tell you that you can use one when you take a test.
Yeah,
Okay.
Like, if
Definitely
they don't give
fail.
it to us, can we just use yours? Like,
I would.
So, yeah, they're going to be the same across the board. So, I actually sometimes print the one out of the AP book instead. That's why I was like, they may actually be in my AP prep packet because I have, like, a packet that I give people that has, like, everything that you could need for stats in it, like all the formulas and all that. They do give you some formulas on the exam, but I want to say you do get your calculator for the whole thing, but sometimes they may want you to use the table or explain how you did it at the table, depending on the question. So, it's always good to know both methods. But your calculator is obviously more efficient typically. So I'm going to show you how to do that now. So if you're using your calculator, normal CDF, okay, so that's the function there, will solve for percentiles. The menu is going to read, so basically what it's going to ask you for. So lower, so what's getting plugged in here is the lower boundary, Z or the value, the upper is the upper boundary, so Z or the value. Mu is obviously the mean. Sigma is your standard deviation. If it doesn't give it to you, that information that you need, you would use 0 and 1 for mean and standard deviation.
I'm kind of ready to you now. It's making me want to go mute.
All right, something to note about this. If you only have one value, okay, in terms of upper and lower, use a very high or low, depending on which thing is missing, number for the other boundary. Now, if you were to go on your calculator right now and look at this, what you would see is that one of them probably says 1E99. Okay? That would be your very high number. The low number might say -1E99. Okay, I don't know if your calculator will naturally do that for you or not, but I'm finding it. Just give me a second. I have to always think about where it is. All right, so hit hit second, and then vars, so it's beside the clear button, and then option 2 is normal CDF. So mine already has a lower of -1 E99 in there. It has no upper value. 0 and 1 is in automatically. If you're given a mean and standard deviation, you need to replace 0 and 1 with that. If you aren't given one, leave it like that. Okay? So when I was doing the problem up to 450, so the first one that we did, I would put in the -1 E99. Upper, I'm going to put 450. Mean is 500. Standard deviation is 100.
Wait, what was the lower? Are we leaving it?
Yeah. You just,
Lower is the -1 E99. It didn't give us a lower in this one.
you just put
It just
lower.
basically said the percent of students that score below 450. So 450 is going to be my upper. It's going to then ask you to paste it, and then once it pastes, you're going to have to hit enter one more time for it to actually give it to you. And it gives you this really nice long decimal
That's
number.
So cool.
So the table's only going to give you out to 4 decimal places. This will give you more. Okay? Something I'm going to write as a note in a minute, but do not round until the end. Let your calculator hold your precision for you. Okay? If you don't know how to store this number in your calculator, if you hit the STO with the little arrow above on, okay, and then you hit alpha and you can pick your favorite letter. Okay, so I'm going to pick S. Hit alpha and then whatever the green letter is, and you hit enter, it stores that number there. Okay? You
So
see
then
that?
if you were to quit and then do alpha, that's
So if at any point until you take your batteries out of your calculator, you either don't replace it or whatever, S is always going to stay that number.
Huh,
So how do I get rid of it?
Replace it with something else.
that's so cool.
Store something else there. I know,
I
it's
didn't know
wild.
you could store things.
That's what STO means for.
Mm-hmm.
R will forever be.
It's crazy how much you like continue to learn about calculators. Like
So then the next one that we had between 450 and 600, let's go type it in again. But instead of -1 E99, you're going to type in 450 as your lower, 600 as your upper.
So we're doing normal.
So second vars,
That was like
normal CDF. So I'm going to have 450 to 600. It kept my 500 and 100 for me. Oops.
So the upper 600?
Yes.
Whoa.
Paste it.
Sure did give it to
Boom.
me.
If you had to do them separately, that's why we would want the stored value.
I feel like this is better than doing it on the table.
It is.
But like I guess that's just for like if they don't give it allowed in the calculator.
Right.
Okay.
It's good to know how to use both. I would say typically use your calculator.
Okay.
But I would caution you that if they were to give you a short answer problem, you probably should do it by hand
Yeah.
and then verify it with your calculator.
Okay.
And what they tell you is don't assume they know your shorthand. So like when I've taught it before, I've said if you're going to do it on your calculator, let's say you forgot how to do it by hand or you're going to show that you verified it with your calculator, tell them everything you're typing in. Tell them that you typed in normal CDF. Show them what your upper value. Like don't just assume that they know that the first number you say is your lower and the second number is your upper.
Yeah.
Specify what everything is so that
Be
when you get
specific
down
on
to the
everything.
answer, be as specific as possible.
Right.
All right, we'll come back to the other example when we do the next thing. All right, so then, and just to note, this is second vars that gets you to this point here. That looks awful the way I just wrote that. Second vars. So then the next function is going to be found in the exact same place. So instead of option 2, it's going to be option 3. So INV norm. And don't ask why they capitalize the N in norm, but they do.
Nice.
INV norm will give cutoff values.
So like the
So when,
last example. Well, not last,
Yeah.
but like yeah, you know what I'm saying.
yeah.
Okay.
So cutoff values or z-scores, it can tell you both, if I remember correctly. But it's going to ask you for area, which just means the percentile, which is nice because you can tell it exactly what value you want. The problem with the table is we're at the mercy of I've got to round. Basically, I've got to go up to the next value. And here you can type exactly what it is, and they can give you something more precise than 1.29. They could give you 1.285 or whatever it comes out to be. So then it'll ask you for mu, which is your mean, sigma, which is your standard deviation. And then just another thing to note here, if you use z-scores, my pad is very glitchy, use n, 0, and 1, so if you were using z-scores, so basically if they didn't give you a mean and standard deviation, use 0 and 1 to the same thing that we said for the last thing. If you use actual data, the mean and standard deviation of the data will be mu and sigma. So just a note, I kind of said this earlier, don't round until the end of a problem. Let your calculator keep all the precision. So if you hit second vars and you go down to IMV norm, the area is whatever percentile. So ours was 90. Mean was 500. Standard deviation was 100. You're going to paste it.
Is it error?
Oh, hold on.
What do we do with the tail?
Mine's a domain error.
Hold on a second. Let me see what happens if I do this. One second. Nope, I hit the wrong button again. Oh my gosh. Oh, hold on. I know what the problem is, I think. Before I tell you to type something else in, let me check. Okay. So we can't put in the percent itself, so we can't put in 90, we have to put in 0.90. I always forget that. So percentile, I'm going to make a note here as a decimal. So you're going to type in 0.90, then 500, then 100, and it'll tell you that the value was 628.155, and so on and so
What
forth.
do we do with the tail? What are we putting?
The tail.
What tail?
Oh, because
What
your
tail?
calculator. This is where their calculators are different because they have the newer calculators. You have to put that you want the left side. No, well, you want the right side. Sorry.
Right side?
Right side. That's where you're going to need to look at the picture. Our calculator is only going to do it one way. Hold on, I have to think about it. I may have just told you wrong. It might be left still. Ours automatically does left. So you might have to do left, or you might need to type in the top 10%. You might need to type in Okay, I know what it is. All right. Sorry. I don't have that calculator, so I always have to think about it. Okay, Josh and Nathan, if you want, because yours asks for the top 10%, you can type in 0.10 and then choose right.
For area?
Yeah. So an area, you can type in 0.10,
Yes.
and then when you choose the option for the tail, you need to choose right. If you type it in the way that we do, you would type in 0.9, and then you would type left or click left.
Okay.
Our calculators automatically do left because before they got techie, you had to just do left, and then sometimes you have to do like 1 minus if you want something else. It's entertaining. Did y'all get it?
I got a number, yeah.
Did you get something like 628 point something or 629?
I got 628.55.
Okay. So yeah, so obviously our number out of the table is a little different because we only had the rounded value to work with. So that's why this number is going to be a little bit higher than the number we actually got off our calculator. So
The calculator one would be more accurate.
yeah, because it can do it out exactly. It's going to keep the precision for you, whereas we're losing some because we're having to choose that 0.9015 for 90.
0.90.
Mm-hmm. So yeah. Any questions about that? All right. We'll have examples on